In this video, I am going to talk about ratio, and this is how ratio can evolve. So what does this mean to you is when you study ratio, do not just study ratio as a topic. So here goes. Ratio. Okay, so first of all, when you study ratio, I think it's easier to study as a problem sum type, or rather to study the problem sum types that have ratio inside. And the reason is because when you are able to solve problem sum type with ratio, that only means that you understood ratio. Yep. Okay. So the most common example will be RI, not Raffles institution, but it is repeated identity. And for repeated identity, what this means is that you have two, okay? Okay, this is not money. Yeah, I'm trying to draw a hand with two fingers. Okay, let me try again. I think this is much better than drawing like that because it looks like a bunny. All right, laughing at my own jokes and my poor drawing. Okay, so when all else fail, just put a two. Two names or identities and one repeated. Okay, so the method, same thing. This is what you see. In this case, I have it reversed. This is a concept. And this is the method. Like, what do you do now? You have name one is to name two, write down the ratio, and then you have name two is to name three, write down the ratio. You can see these are the eyes. It looks creepy. Okay, leave it as blank. Then make this the same. Make same. All right, that's it. And of course, because this is also under repeated identity, there is a type 2. So there's a type 2 that you learn in P5. Then I will call this type 1. Type 1. For type 2, in fact, you do not see any ratio in the question. You only see numbers. And you see another sentence with B has as many times as C. So let's say this is A and B. This is A and C. So B is as many times as C. So same thing, this is under repeated identity as well, type 2. And then you have to first find the number of units equals to what number. And bearing in mind that even for ratio, after you have found the final ratio, let's say it's 1 to 2 is to 3, it's actually 1U is to 2U is to 3U. And because there are units involved, when you have units involved, you know you need to find, okay, C units, find 1U, And that's when you make use of the given number. And what does it mean by given? Means that the number is literally given in the question. Okay, so make the number in the question your best friend. And in fact, this is so important that it applies to any questions with units. In fact, almost all problem sums in the Singapore primary school math require you to understand that the number given in the question is for you to find one U. You may want to verify, don't trust everything that I say. What I'm saying is they are all from my own teaching experience and how I coach many students as well as my own kids as well. And I'm not MOE trained. What I'm doing here is I want to just make math more child-centric and easier for the children to understand. Okay? So you take whatever that works for you. Then, in this case, this is actually B. This is C. All right. So this one, just leave it as it is. Okay, so when you have repeated identity, because we are talking about ratio now, then you realize that there are many questions that require you to use ratio to solve, and one of them is one unchanged. And when you hear of the word one unchanged, you need to think of the siblings, and they are same difference, and next will be same total. So remember these three siblings together, okay, together. All right, so what this means to you is you have to look at the layout. Yeah, so this is what we call layout learning. And in fact, this is one of the highlights of LOB teaching. We taught children in learning out of the box layout. So when they see this, they draw this. When they see that, they draw that. When they see something else, they knew exactly what to start off with. So for the one unchanged, in fact, there are only two names. And you draw the BCA table. So two circles on top, two circles for before, two circles for after. And say if N2 is the same, you have to fill in the change for N1 because N1 is the one that changed, and for the one that didn't change is N2. Okay, for the same difference, let me use another color. I think I just use black, okay? Same thing is the BCA table. BCA table. You have N1, you have N2. And the highlight here is because it's same difference. Your third column is difference. So 3 circles above, 3 circles below, and equal change for both. Then for same total, it's the same layout for same layout as same total, just that you change the difference to total. Then you have a BCA. So you have 3 circles above, 3 circles below for the ratio to be filled in, and then equal rise equals to equal drop. Okay, if you have no idea what I'm talking about, please rewatch the video. These are some things that all primary fives should know after June, okay, right after June. Or maybe August. It depends on when ratio is taught to the class. Okay, so the only difference is here. And then this is only one circle. So same thing. make same, make same. Okay, make them the same, make them the same. Okay. Okay. Then, since you're talking about same total, some of you will be asking, so what do I mean by equal rise equal to equal drop? Okay, so again, let's go back to the three musketeers or three siblings. For same one, I think that's about it. There's only one variation, and normally they will test you with ratio. For same difference, it depends. Okay, so for same ratio, same difference, other types. Okay, other types. Based on what I know for one unchanged, I think there's none. So none. Okay, just across. For same difference, you can talk about age. Okay, so there's one type which is the age. When you see age is same difference because of equal change. Next year, my age plus one, your age minus one, or plus one. Then when there's age, you got to know that you can use model. Okay, you can use model, or you can use ratio. It depends. Sometimes they give you ratio, so you use ratio. The second type will be, they mention equal change. It can be equal. They literally mention equal change. Okay, equal change, equal drop, or equal rise. And if it's a model, let's say if it's a model, you cut in front for equal drop, or you add in front for equal rise. Okay, let's say I put here, you have to cut and add in front. Okay. Wow, so much to cover. If you're watching this weeks before PSLE, I hope you have been taught all of this. Okay, so for same difference, there are three types in total. One will be, like they mentioned, plus 12. Let's say 12 oranges and 12 pears were eaten, or 10 girls and 10 boys left the room. So equal number. Equal number, same direction. Is both increasing or decreasing. Okay? Or sometimes they just tell you equal change. Yeah, so sometimes they mention equal change. But I think most of the time they'll tell you it's either a drop or a rise. Okay, then when you study this one, please study with accumulated difference. No idea what is it? Go and ask your tutor. Okay, so what this means is that probably it can be related to questions on savings, and say across how many months both of them, A saves so much and B saves so much. Or in a year, A saves X dollars, B save Y dollars. Then somewhere down the road, they mention in a sentence or two, in a month, A saves so much and B saves so much. Yeah, so you have the big difference divided by a small difference. Okay, and somehow that also may spark you off to get some check. But let's not go there yet, because I think it will just further confuse you if you're not trained in conceptual understanding. Again, for the fact that many of you came in because of final sprints, CPS, PRC, or any other workshops by Coach John and our team, you should be very familiar in this by now. Okay? And if you are someone who happen to receive these videos from your friend and you ask your kid and your kid is taught by somebody else and they have no idea what's talking about, you may want to check in with whoever is teaching your child to make sure that they are learning the right thing. Okay? Okay, what about same total? Okay, same total got two types. One is internal transfer. Let's say I pass to you, you pass to me. And doesn't matter how we pass to each other, the number of things that we have in total is always the same. Number two will be the rise equals to drop. Okay. 10 boys left the room, 10 girls came in. 2 girls left the room, 2 boys came in. Okay, I can't remember whether I said this correctly, just to clarify. Let's say 12 pears and oranges. 12 pears and 12 oranges were sold. 10 boys and 10 girls left. 10 boys and 10 girls left the room. Okay, so in this case, it's 10 boys left the room, 10 girls came in. Okay. All right. And when you see internal transfer for same total, if it's ratio, you will use your ratio method. But let's say, okay, if let's say there's no ratio and they're all numbers like A has 20 more than B, and if A give 10 to B, A will have say 20 more than B. Doesn't okay, I mean the number may not make sense to you, but you can hear that there's no mention of ratio at all, and it's all numbers. That's when you need to draw. Remember, when you hear more than and is internal transfer, so it's more than plus internal transfer, more than or less than. Remember what we discussed earlier? Draw model. Okay, draw model. Yeah. Draw model. Okay, draw model. Model. And the interesting thing about this is when you pass something to, when you pass, say, 2, when you bring it down, 2 should be here and here should be 2. And we'll call this 1 unit. So somehow this is like symmetrical. Okay, symmetrical. All right. Okay. Okay, so I think that's about it for ratio method. And again, if you are a tutor or educator and you learn something new and you want to share it with your own students, please let them know that you learned from us. Okay, I appreciate that. Thank you.